Assalamu alaikum wa rahmatullah, and good afternoon to all the respected viewers of the Voice of the Capes YouTube page as well as the Voice of the Capes Facebook page. It gives me great honor and privilege to once again to introduce our brother Imaad Isaacs on behalf of Futures Academy SA's online high school. And of course, this is the DOC's annual Matric revision program that we are running in collaboration with Futures Academy. For today, inshallah, as all of you, our beloved matriculants, are preparing for your up and coming NSC examinations, which we wish you all the very best for. We are going to have a continuation for the preparation of mathematics paper one, in particular dealing with the subject, with the topic rather, of calculus. So without further ado, we immediately hand over to Brother Imaad to continue from where he left off yesterday. And this is, of course, dedicated to all of the matriculant students for your paper one maths preparation, and in particular the topic being calculus. Over to you, Brother Imaad.
Okay, shukran to our brother Amir there, Mr. Amir Adams in the studio. Inshallah, today we focus and we continue with this idea of calculus. Yesterday we covered limits, evaluating limits and the limits that you see in the grade 12 curriculum. And we covered a method which was the plug and chug method. And what we said over there is you simply substitute, one of three things will happen. Either you're going to get a value or you get an indeterminate form such as 0 over 0, and then you have a little bit of extra work, or you get an undefined solution or something tending towards infinity. That's where you have some number or some value divided by 0. Okay, so let us continue. So that was limits. Then we also tackled differentiation, and we tackled differentiation using the rules. Okay, and we spoke about a polynomial function. A polynomial function, we've seen linear functions, we've seen quadratic functions, you've also been exposed in class to cubic functions, and all of those examples of polynomials. And that could simply just go on and on and on and on by raising the degree further and further. So we have a coefficient, we have a variable, and we have some power. Okay, and that will give you the polynomial functions that we had considered. Okay, so today we want to continue with first principles. We want to talk about deriving things with first principles. But before we do that, we're actually going to touch on the average gradient. Then we're going to revisit first principles by after touching on the average gradient, and we're going to join that by introducing the idea of a limit. Okay, so let's make that work, and let's do something with that quickly. Okay. I must be very honest, I don't think I've actually taught this section in a number of years. So let's just find a space to work over here. Okay, so let's go. We're going to talk about the average gradient, and the average gradient will give us an idea of working towards the instantaneous gradient. Okay. Okay, so average gradient. Now, what is the average gradient? Now, before we even talk about an average gradient, you know that when you studied analytical geometry and you looked at curves and lines, you were given an idea of the average gradient. It's really the gradient that you know, right? Let's make this a little bit thicker and color there. So if I take a line and I draw that line over there, then we know that the gradient is given by rise over run, right? So let's just take that like that, and this little distance that you find over there, the rise, right, or the change in y divided by the run. So that's delta y, and this is going to be your delta x. Change in y over change in x gives you the idea of the gradient. Okay, but for a straight line, if I run the same amount of units, let's say this is 2 units, and that's also 2 units, then if I maintain running 2 units, I will rise by the same amount each time, right? So in other words, for a linear curve or a straight line, we say that the gradient is constant, okay? The gradient here doesn't change. Now, if you get an idea of gradient and you think about gradient as the steepness, let's just talk about the effort that I would have to put in if I was Johnny over here and I had to run up here, okay? So let's just see if I use this. If I am running here, that's me, that's little Johnny, and I run up. Now, because the incline is the same throughout, I might have to exert the same effort. So in other words, we will say here that the gradient is constant, right? The gradient here, the rise over run, that ratio of rising by running does not change. Okay, so that's a constant gradient, and that happens for any linear curve or straight line. Now, calculus is particularly interested in what happens on other curves, okay? So let's just take this curve that looks like that. What does this mean? If I look at the steepness over here, then the gradient is consistently changing. Over there, there's going to be a bit more effort that I have to put in when I'm running here versus when I'm running over here, right? Versus when I'm going downhill. So here, the gradient is consistently changing. Okay, now let's put the ideas together. Firstly, we've got gradient. We know the gradient needs to involve some idea of an incline or a slope with some measure of the steepness over there. The other thing is what defines a line, right? And what defines a gradient. Now, when we consider this, right? When we consider this, when we think about a line and we think about a slope, we need to have 2 points, right? So if I take a dot there and I put a dot there and I join the 2 dots, it's known as a line. Okay, now for a slope to be defined, we can look at the formula. We have m is equal to y2 minus y1 over x2 minus x1. Now we know what the y2 and y1 and x2 and x1 relates to, right? This relates to a set of coordinates. So let's say I've got coordinate A, a point A, which has got coordinates x1 and y1, and I've got point B, right? One point on the Cartesian plane, another point on the Cartesian plane with x2 and y2. Then the gradient between those 2 points, for example, being A and B over here, will be that y coordinate minus this y coordinate divided by this x coordinate minus this x coordinate over there. Okay, now this value doesn't change when we are dealing with a straight line. Okay, and all that means, again, the gradient is constant. So what's the idea of average gradient? Now, if I talk about the average gradient and I give you this point over here and I say that's point A, and I talk about this point over here and I call that point B, then the average gradient is simply the gradient, ooh, that doesn't look great, is simply the gradient of the line that joins those 2 points. Okay, so if I had to talk about, let's say this is this guy's mood, right? And I don't know, we've got some measure of happiness happening over there, and we say this is little Johnny's mood over time. So there he was fairly happy, the mood was good. Here, you know, then started going downhill, etc. If the trend has to be analyzed over here between points A and B, we'll say that that trend is generally positive. Okay, and that there is because we're looking at the average gradient of the line that, or the gradient of the line that joins those 2 points. So, question, what is the average gradient? It's simply the gradient of the line that joins those 2 points. Okay, so now we've got a question. What's the formula for average gradient? It's just your regular gradient formula that you have. Okay, so let me take a curve quickly, and then let's find the average gradient between 2 points on that curve. Okay, and then once we're done with that, then we'll look at building the idea of the instantaneous gradient. Okay, so let me take a curve. Let's take a graph, and there's my graph, right? And let's take a parabola and make the parabola x squared, right? So there we go, and there we go. Okay, I just want to see these enhanced int shapes. Let's just see if that improves anything. Let's see if I do this. Okay, I don't see any improvement there, but nevertheless. So let's just say that's a parabola, and we're looking at that parabola, and let's just say that this parabola is y is equal to x squared, right? So if that's y is equal to x squared, let me take 2 points. If I take 2 on the x coordinate, so you substitute 2 in there, you know you're going to get 4 for y. And let's take 3 as the other coordinate, and then we know 3 squared is going to be 9, right? So if I ask you, let's say a question reads, and they give you this graph, and they give you point A, and we say A is Let's just make 2 over there. 2 is there, and let's just say 3 is here, right? So if 2 is there, I'm sorry, that's definitely not drawn to scale. Yeah, no, it's fairly drawn to scale. So 2 is there, and that's going to be 4. This is going to be 3, so you know that corresponds to 9. Now, if we ask you to find the average gradient between point A and point B of this graph, all you do is find the gradient of the line that joins A and B. So if you take A and B, and it's joined over there, there's my line. I'm sorry, I don't know why that's not so bold, but okay, there's the line. Okay, there's the line. So we can see something that slopes this way is positive. Something that slopes this way is positive, right? And to find the gradient, you choose a set that's going to be your coordinates for your x1 and y1 and x2 and y2. So let's just say this is going to be x1, y1. That's going to be x2, y2. Then the gradient, the average gradient between points A and B is simply the gradient of the line joining A and B. So that's going to be m of AB is equal to y2, which is 9, minus y1, which is 4, divided by 3 minus 2. What's 9 minus 4? 9 minus 4 is 5, and 3 minus 2 is 1. So the answer is just equal to 5. Okay, so let's write a few things down and see what's in the average gradient, right? So let me give you a few things and you tell me what the average gradient looks like for each of that, okay? Let's say I have, example 1, I've got a set of coordinates that will be A and B, and the other point, right, will be C and D, okay? Number 2, what's number 2? Number 2, let's take the points 4 and 7, right? And the other point being 13 and 11. Then let's take another one. Let's give you the third one quickly. Let's give you a graph. Okay, before we even go to a graph, let's give you cow, right? And Tom. And let's give you chicken and Jerry. Okay. Okay. So cow and Tom and chicken and Jerry. Right. So let's start at the top. Remember, for gradient, this is coming from your analytical geometry, but it's very relevant while you're doing it here in calculus. Choose this as my x1, not x2, x1 and y1. The coordinate set must be maintained, and x2 and y2. Okay. So x1, y1, x2, and y2. So let's see. Remember, the formula will be y2. So the y2 for the gradient here, it's going to be d minus b divided by c minus a. Okay. For the next one, what will the gradient be? Once again, this is going to be m is equal to the 11 minus 7 divided by the 13 minus 4. So what's 11 minus 7? Well, 11 minus 7 is 4, and 13 minus 4 is 9. So the answer here is 4 over 9. Okay, for the next one, we take the y coordinates and we subtract. So Jerry minus Tom, in this case. Jerry minus Tom over chicken minus cow. Okay. Right. Now, it's perfectly valid to say Tom minus Jerry as long as I say cow minus chicken, right? Because that simply means that I've ordered this to be my x2 and y2 and this my x1 and y1, right? And then if I do it like that, I can also say it's going to be Tom minus Jerry divided by cow minus chicken. Cow minus chicken. Okay, So now we have an idea of what the average gradient is. Now let's see, can I make average gradient a little bit more complex? Well, guys, it's simple revision. So let's just give you one quick example where we give you the function and we give you the x values. So if I tell you determine the average gradient for the function between two particular x coordinates, the function being f of x is equal to 3x minus 1, okay? Determine, remember question can read as follows, determine the average gradient. So let's actually write it out. Determine the average gradient, right, of this function f of x between, okay, x equals to, let's make it 2 and let's make it 6, right? Between x equals 2 and x equals 6. Now remember, for the average gradient, you need a set of coordinates, and one set of coordinates gives you 1 point, right? So when x is equal to 2, you're going to get 2 there. Now substitute 2 in. 3 times 2 is going to be 6. 6 minus 1. 6 minus 1 is 5. So that's my one set of coordinates. And the other set of coordinates is when x is equal to 6. I need to find out what's y. So I substitute the 6 in here. 3 times 6 is 18. 18 minus 1 will be 17. So that's going to be 17. So that's my coordinates, right? So now we can determine the average gradient. The gradient will simply be 17 minus 5, taking the one y minus the other y, divided by 6 minus 2, right? Now we get an answer. 17 minus 5 is 12. 12 divided by 6 minus 2, that's going to be 4. And 12 divided by 4, the answer is 3. Okay, now, okay, so 17 minus 5 is 12. There we go. Now, let's say we turned it around and we said, take this y minus that y. That's perfectly valid. So we can also say it's going to be 5 minus 17 divided by 2 minus 6. And what's that going to give me? 5 minus 17 will be negative 12. Divided by 2 minus 6 will be negative 4. And negative divided by a negative will simply be a positive, and that's going to be positive 3. Right. So important things to remember when calculating the gradient. Number one, y is on top. Number two, your x1, y1 must be grouped together. So I can call this x1, y1, and I can call this x2, y2, or I can call this x2, y2, and this x1, y1, as long as the ones are grouped together and the, the x2, y2s are grouped together. Okay, I'm sure you're all with me. Okay, guys, so now we've got an idea of what average gradient is. It's just the gradient you've always known. Group them together, y2 minus y1, there you go. Okay, so we've got an idea of what's happening over there. Now, if we go back to what we discussed earlier, we are interested in instantaneous gradient. Now, for the instantaneous gradient, people, let's take a few things. The derivative in calculus is the gradient at a point. It's also known as the instantaneous gradient. Now we're sitting with a bit of a conundrum. And what is that conundrum? Well, number one, to create a line or to get some kind of an idea of a slope, right, I must have 2 points. And yet calculus is telling us, guys, let's go and solve and find a solution to the gradient at a single point. Oh my word, how are we going to do that? Like what in the world? Let's not swear. What in the world is that? Okay, and so here's where things get exciting. So let's take a curve again, right? Let's take a curve, and let's just see, can we make this thicker? Yeah. Let's see. Yeah, that looks nicer, right? Oh, okay. 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 So now let's take a curve and let's see what this curve is going to look like. Let's take a graph and let's say the graph looks like that. Just to give us some more space, okay? Now, if I ask you to give us the gradient between let's take this point, and I'm going to call this point x, right? And then I'm going to call this another point, okay? And let's just say there's a distance here, and that distance is h, right? Let's say that distance is h. Now, if we were to use real numbers and we say that this number is 1, and we say that this distance from this number over here to this number over here is 3, then we know that that point over there is going to be 4. Now, how did we get 4? If this was 1 and the distance is 3, we said 1 plus 3 gives us that 4, right? So in other words, this coordinate over here will be x plus h on the x. Okay. Now, if I go over here and I go over here, right? I go over there, and let's just say I call this curve f. I call this curve f, right? So if I were to call this curve f, I want you to take 30 seconds quickly to determine what this coordinate, what will this corresponding y value be, and this corresponding y value on this side. Okay, take 30 seconds to work that out quickly. Okay, so let's consider what that would be, right? If you consider what that would be, then, right, if you consider what that would be, then you know that the corresponding y value pops out f of x, right? And the corresponding y value over here also pops out f of x plus h. Because how do I get the y value of a particular function, right? I substitute in x into whatever that function's value will be. Now, we've just established coordinates. We've really not done anything yet at this point. So let us quickly go and have a look. If I ask you, if I join these 2 points, right? I join this point over here, x, and I join this point over there, then you can tell me, well, Imaad, when you join them, you get a line and you get a straight line. Okay? Now, take the point where x is x and x plus h. If I ask you to determine the gradient between those 2 points, or if I ask you to determine the average gradient between those 2 points, we've just done it. We've done it a few times. You'll be able to say the following. What can you say? You can say, well, what are the coordinates? Well, the coordinates are x, and the corresponding y value is f of x. The other coordinate is going to be x plus h, right? And the corresponding y coordinate is going to be f of x plus h. Okay. And now if you want to determine the gradient between those 2 points, all you're going to do is you're going to say, well, the gradient between those 2 points is equal to f of x plus h, right? That's the y value, like a Tom or Jerry or cow or whatever we had in the previous example, minus f of x. Okay. And when we divide that, we're going to say, well, it's the x coordinates in the same order, that one, which is x plus h, minus this x over here, right? And so that's the gradient. Now, the problem we're sitting with is that's giving us the general trend. It's giving us the average gradient. Because if I ask you what's actually happening on this curve over here, you can say, well, Imaad, things seem positive. They're sloping upwards. Generally, things are getting better, right? But we're not really interested in the gradient between these 2 points. With calculus, we're interested in the gradient at a single point, okay? So let's just say we take another point. Now you can see what's happening over here, right? And let's say I join a line between those 2 points. What can you say? Right? Remember this green line that you see over here has a special name. It's called a tangent, right? And that tangent line, you can see this has got a greater gradient than this tangent line. And the pink line and the green line are both tangents. But let's say I decrease the distance even further. So you see that's the distance I'm looking at over there. Let's say I take another point and I go even closer, right, to this point over here. And I'm going to join the two lines once again. Let me join them again. Let me join them. Let me see. Right? Okay. If I join that over there, I can see that this tangent line, by reducing the distance between the 2 points, green and pink, I'm bringing the points closer and closer and closer and closer. So let's just say I bring it, if I bring it all the way, then I'm eventually going to sit with this point, right? Let's just see if I've got another color. Let's bring it a bit closer. Let's make it black. I'm going to draw a point over there, right? I'm drawing a point over there. And let's just say I do this. What's happening to that distance that was initially h, right? That h became this length over here. Then it became that length over there. You see that? Then it became this length over here. So as I bring this point that is laying here and I drag it along that curve closer and closer and closer and closer and closer, the distance between the points that we initially sat with is going to tend towards 0. That's the word. It's going to tend towards 0. Okay? Now, why am I doing that? And I don't know if you can see where I'm going with this just yet, but to get a gradient, we must have 2 points. Calculus is saying, let's find the gradient at a single point. And now we're saying, eventually when you take 2 points and you bring them infinitesimally close, it's almost like sitting with a 1 point on top of the other point. Essentially, that's really what we're trying to do. Now, to truly have both points on top of each other, right, we won't really get a gradient. And that's where the idea of a limit comes in. So this here is the average gradient. But when I take the same thing over here and I introduce the word limit, right, in front, and I say f of x plus h minus f of x divided by x plus h minus x, you see here, I'm only left with h, right? And if I drag one point and I bring it all the way on top of another point, okay, it's 2 points that are essentially now like 1 point, okay? Okay, almost like 1 point. However, 1 point doesn't solve the problem of a gradient. So we say h tends to 0, right? We're trying to get infinitesimally close. We are approaching that limit by making the distance virtually 0. And by doing that, that gives us an opportunity to actually get an accurate reading for what the gradient will be at that instant. Okay, so we denote this as f prime of x. This over here is actually the definition of the derivative. Okay, so let's give you a few seconds quickly. Just take that down, and then we will go over 2 or 3 examples very quickly of applying this definition. Okay, so now that you've got that down, right, let's look at a few examples very quickly. Okay, so guys, remember, we are really crash coursing this because there's going to be some things that you are fairly familiar with. So let's look at differentiation from the first principles. Okay, right, now, I want to bring this back to the derivative. When we spoke about the derivative, remember the derivative. What was the derivative? The derivative was really a shortcut for determining the gradient. It is the gradient at a point, right? And when we spoke about the power rule was a shortcut to finding that gradient at a point. So now what I need you to look at, if we think about this very quickly, the derivative, okay? We said two things. One was power rule, right? The second thing was using first principles. Yeah, and yesterday we had a little bit of a spelling error. First principles. Okay, so let's do a few examples. Let's say the function is f of x is equal to 3. Hey, mama, what are we doing there? F of x is equal to 3. Okay, so when you look at that, f of x is equal to 3, you know that that graph is going to be a curve, right, that is a horizontal line that cuts through 3. Okay, that is exactly what that line looks like. Now, if the derivative is simply the gradient at a point, right, what is the gradient of that line? That's a special line. The gradient of any horizontal line that is parallel to the x-axis will be 0. So in other words, what we see over here, right, when I take the power rule, remember that for the power rule, I say f prime of x is equal to, remember there's an invisible x to the power of naught over there because x to the power of naught is equal to 1. And I say 0 times 3 will simply be 0. Okay, that's my derivative. And here graphically I can see it as well. But according to first principles, the structure is I need to find it using the rule. So I say f prime of x is equal to f prime of x. I write out the full formula. And depending how the examiner has set up the question paper, they can give you a mark for this formula. So generally in mathematics, there's no marks or formulae. However, there could potentially be a mark for this, right, in this particular section. Okay. Now, so you write it out. Now you substitute. Now, before we even substitute, candidates, I want you to look at this. Sometimes this throws students off. But f of x, right, is equal to 3. So what is f of x plus h? Wherever you see x in this equation or this expression, right, or this algebraic expression for this function, what you need to do is you substitute in x plus h. But now look at it. Is there even an x there? There's no x. So f of x plus h is just equal to 3. Now when you substitute over here, you're going to say limit as h approaches 0. F of x plus h, you're going to put in there is 3 minus f of x's value, which is this. We're just going to substitute that in, and that's also going to be 3, and that's going to be over h. Well, take the numerator over here, and we get limit as h approaches 0 of 0 over h. Now, you can evaluate this. You don't even need to substitute in at this point. And what you're going to get, 0 divided by h is simply 0. Okay. So now let's take a few examples in which we incorporate a few variables. So I'm going to write down the variable, and then I'm going to give you a minute or two to just try that quickly, and then we'll continue with the solution, right? Now, what I want you to remember before you go into that, remember to write down the derivative correctly, write down what your f of x will be, write down what your f of x plus h will be, and try and use the shortcut rule to find the solution before you even attempt this, to see if you're going to get the same answer. Okay, so give me a thumbs up if you guys are ready. Okay, awesome. Right. Okay, so let's see. Let's take a simple example, and then we're going to go into a more complex example. So for the simple one, let's take f of x is equal to minus 4x squared. And now the question is, find the derivative of that. In other words, find f prime of x. What will that equal? Okay, let's give you a few seconds to write that down, and then we will start with that. Okay, so now that you have the question down, remember, you have some idea already as to where to go with this, okay? So let's see. Right, we want the derivative. So to get the derivative, write down the full definition, and we want you to do it with first principles. So f prime of x, it's equal to limit. Now guys, you can be penalized if you don't write the limit part, because the notation is part of this definition, and they will give you, if you get everything correct, even the correct answer, but you don't write limit all the way down, then you'll get, if it's a 6-mark question, you get 5 out of 6 marks. If it's a 4-mark question, you'll get 3 out of 4 marks, because it will penalize up to 1 mark for the notation. Okay, so this here is divided by h from the definition. Okay, so now what I want you to look at very carefully, this is my function f of x. Okay, you were told to find this over here. So let us substitute in. Let us substitute. If f of x is equal to minus 4x squared, okay, and f of x plus h is what you also need to find out. So I'm doing it here on the side so that I can easily substitute it in over there. This is going to be minus 4 into x plus h all squared. Okay, so minus 4, this whole thing over here, you know, is going to be x squared plus 2xh plus h squared. Okay, and you can multiply that whole thing out, and you can simplify it if you want to. I'm going to just indicate where the simplification will take place, and then we'll substitute it in over here. So now we've got our materials to work with. Okay, and so now let us go and substitute the limit as h approaches 0 of f of x plus h, and that will be minus 4 times x squared, so it's minus 4x squared, multiplied by negative 8xh, right? Plus, sorry, minus 4, h squared. Sorry guys. Thinking about a lot of things here. Okay. Then I'm going to put in a minus sign, and this minus sign is coming from this, so that's minus. And remember, because it's negative, open a bracket so that you're aware of what needs to happen here. And this here, I'm going to substitute in the f of x component. So that's going to be minus 4x squared. Okay, all of that is divided by h. Okay, all of that is divided by h. So now, what do we do over here? We leave the notation limit as h approaches 0. Very important to have it over there. This minus 4x squared, when we multiply this in, we get positive 4x squared. And you can see that and that cancels out. In the numerator, I'm now left with minus 8xh minus 4h squared divided by h. Okay? And at this point, I'm going to say it's still equal to limit as h tends to 0. I factorize. Why do I factorize? Because I want to get rid of that, right? I factorize the h. So I pull out the h, and I'm left with negative 8x minus 4h, right? Divided by h. And there I cancel the h's. Okay. Now, candidates, at this point, I'm going to evaluate the limit. And how do I evaluate limits? We learned it yesterday. We plug and we chug. So that h, when it tends to 0, all I need to do after this is I put 0 wherever I see h. Remember, this h over here cancelled and this h cancelled. So minus 8x minus 4 times 0. The answer is just minus 8 times x, because minus 4 times 0 is just minus 0. So this whole minus 0 can fall away. Okay, and that's your answer. Now, I mentioned something earlier. I'm sorry, my head is a little bit full at the moment, multitasking here. But when we started, the shortcut is to take the power rule. We say 2 times minus 4. So that's going to be minus 8. Okay, minus 8. Minus 8 is the answer. X to the power of 2 because I used to have a 2 over here. I take 1 away, and I'm going to end up with just minus 8x. So now we're assured that we have the correct solution. Now, ladies and gentlemen, we have about 1.5 minutes remaining. So for that, I am going to quickly give you some homework. I also want to incorporate some examples of questions that, some questions that, let's give you some examples quickly of questions that are a little bit more complex. So g of x is equal to x squared minus 3x. That's one question. X squared minus 3x. Let's give you another one. F of x is equal to 1 over x. And then I want to give you another one. Let's give you one more question where I say f of x is equal to 1 over x minus 1. So this one over here is fairly simple. This question that you have over here, x squared minus 3x. Because again, simple substitution. This one over here, a little bit more complex because it's going to test your knowledge of algebra. And a question like this is worth 5 marks, right? 5 marks for this question. A question like this one could be worth 6 marks. Now again, this is really mechanical and very, very easy. But unfortunately, we don't have time for more. And at this point, I'm going to leave you with just those 3 questions to solve as your homework before the next session. In the next session, we're going to wrap up these 3 examples as well as spend 30 to 40 minutes thereafter on sketching cubic graphs and using these principles. Okay, ladies and gentlemen, thank you for your time. I hope we've had a good lesson. I'm going to hand over back to our brother in studio, to Mr. Imaad Adams. Shukran.
We say shukran, jazakallah khair, and baitra makasi. Thank you very much to Brother Imaad Isaacs of Futures Academy, SA's online high school, for so beautifully giving over today's session on mathematics revision for paper 1. And of course, as always, we say shukran to all of you, our beloved viewers, for tuning into the VOC's YouTube as well as VOC's Facebook page. And to all of the matriculants, we wish you well as you prepare for your upcoming NSC examinations. May God Almighty Allah grant you all the success. And we hope that these revision sessions are beneficial to all of you as you prepare for your upcoming examinations. Indeed, today was continuation of mathematics paper 1, and inshallah until the weekend, or rather up until next week, we will be continuing with the revision sessions dedicated to all of you, our beloved matriculants, in order that you may adequately prepare for your upcoming NSC exams, inshallah. From our side, we wish you well, and we say wassalamu alaikum wa rahmatullah. All the best.